Hello everyone, this is the supplemental practical exercise for the strings, lists, dictionaries, and tuples. So let's get into some examples. So we're going to do some of the examples from the lecture, but we'll also explore a few other examples as well. Okay, so first of all, what I want to do is address strings. They're relatively easy because we've had some experience with them before. So first, a regular string. So for example, I might have a string called Pokemon name. In this case, I've chosen to surround the string in single quotes, could equally be double quotes. What are the advantages of having both kinds of quotes being able to be used? Is that you can do something like this. So maybe I have something like store name. If I were to do something like, Randy's shop, well, the problem is this apostrophe is also a single quote character. So it gives me the option of putting double quotes around it, for instance, and then you can put a single quote inside and it's just treated like a character. By the way, it is possible to use single quotes around a string like this. You just have to use a backslash in it, but that's, I think, a little bit less beautiful. So it is a little simpler to just use a different quote. So that's usually what I'll do. Is I usually use single quotes unless I need, for whatever reason, I need the single quote character inside my string. Okay. All right. The other type of string that we talked about were the binary string. So for example, I could do Pokemon type, and I could just create a string grass. Now these are just ASCII characters, so this is relatively simple. This is the exact same type of string, but when I put in a B here, now it is a different type of string, and let's just see what that looks like. So what we'll do is I will print, first of all, Pokemon name, the name of the variable in there just for clarity, and Pokemon type. Okay, this equal sign up at the end here means that it's going to print the expression itself, and then a space, then equal sign, then space, and then the value of the expression, in this case the value of the variable. So let's run this to see what it does. Okay. By the way, if you get this error message in your Visual Studio, it's just because there's a conda command that's installed when you install Anaconda on both Windows and Mac. This doesn't happen in Linux, generally speaking. All you need to do is configure your path so that it contains the conda command. But for simplicity, there's really no need to change it because this is just trying to create a new environment for you to do your coding in that has specific configuration that's just for the current environment. So that is useful, but in our context, we're just doing really simple applications. It's not necessary. So if you want to, you can just ignore this error message, and at a later time, I'll post something about how to fix it if you really want to fix it. So you just notice in the console here that Bulbasaur just prints out as a string Bulbasaur, and grass prints out as B grass, and that's because its internal representation is actually in binary. But it knows that when we print it out to the console, we need it to kind of be printable characters, and so it converts them to printable characters as best it can. So that means that if it's an ASCII character, it just shows it as ASCII, even though internally, obviously, we're actually storing the byte that represents that ASCII in this string here. But it's really kind of a list of bytes. And then if the character happens to be a non-ASCII character, like one of the other Unicode characters, such as a character in Hebrew, for example, it may convert that into its hexadecimal numeric output representing the bytes that are used in order to represent that character. So that's the key difference. If you have a string, a normal string that has Hebrew characters in it, then it'll just print out the Hebrew characters in the console. But if you have a B string, then it will print out the codes for those, with the exception of ASCII characters. Maybe there are a few other simple types of characters in the 1 byte range. Okay, so let's create a couple of other variables. So I'm going to create an integer variable, base damage. I'm going to set that to 20, and I'm going to have a damage multiplier. I'm going to set this equal to 2.0. So now what I'm going to do is I'm going to use an F string in order to create this string. And I'm doing this because I think some students might sometimes think that this F here has something to do with the print command, because you often use them together. You often call the print function and then you pass to the print function an F string. Now an F string is different than a B string. A B string actually defines it as a different type. Like when I take the data from a B string, I'm actually getting the individual bytes. So it's treated as if it's binary, so I can write it to a binary file or whatever. But in the case of an F string, it's just a prefix that allows you to create a string using the formatted string syntax. And so actually there's nothing different about an F string compared to a normal string, except that inside the string you can put these special characters in there. But in the end, it substitutes the value of the expression in for those curly bracketed expressions and produces a normal string as a result. So let's do that. So let's say I want to print out a message to the console that's saying, something about how much damage we've taken. It is actually possible to use an F string just to create a string variable. So for instance, we could do something like this. We could say base damage times damage multiplier, let's say. And if I wanted to, I can actually print out the expression while I'm calculating this. And then what I could do also is, actually, let's do that. And then we'll put a space, just to put a space in between these two things that we're printing out here. I'm going to print damage multiplier. Since damage multiplier is a floating point, I might want to format it to a certain number of decimal places. Now I know that the value is 2.0, but imagine I set the value to something like 1/3. In that case, I can say damage multiplier 0.2f. So I put this colon in there that says, okay, well, the expression I want to print is on the left-hand side of the colon. On the right-hand side of the colon is some information about how I want this to be formatted. So the F shows that I want this to be a floating point number. So I want to represent it as a floating point number. The decimal just shows you where the decimal point should be. So this 2 is on the right-hand side of the decimal point, which means that I want there to be 2 digits on the right-hand side of the decimal point. And in fact, it is also possible for you to force the fact that it will show a 0 in here by putting a 0 to the left-hand side of the 0.2. So let's print this string. So notice I created this separately, specifically to show you that it isn't something fundamentally about the print statement. I'm actually creating a normal string. So damage message is actually just a perfectly normal string. Okay. So anyway, in this case, you can see that we multiplied 20 times a third, and we end up getting lots of 6s. And then the damage multiplier was formatted appropriately. So it puts a 0 on the left-hand side, and it puts 2 decimal places on the right-hand side. So this is actually quite handy oftentimes when you're formatting strings. Now, you're normally going to create a Python program that prints things to the console. We're normally going to have a graphical user interface or perhaps a web application. But these strings are still useful for those as well. All right, so another kind of string that we might have is a multi-line string. So let's do some dialogue, let's say. So again, I like to use the single quotes. So I'm going to put triple single quotes, and my editor automatically finished the single quotes. And basically allows you to have new lines in here. So I can do something like some of the messages from the Pokemon game is like this. I like shorts. I don't know why they like shorts so much, but anyway. Okay, let's just put the triple quotes at the end of this line so there's no extra new lines in the string. So really, this is the exact equivalent. So if I were just to copy this, this string right here with just a single quote represents the exact same string. It's just that it has a new line in it. Instead, over here, I could just literally hit enter, or I can hit tab if I want there to be a tab. So for example, I can put a tab in there, just hitting the tab key. Those are possible. But the problem is, like, there are special characters in here. This might look a little less nice to you, especially if you want something nice and formatted and you want to make sure that you match a bunch of brackets or match up quotes or whatever inside the string. It's easier if you use a multi-line string. So these two are equivalent to each other. Let me just print them to show what it represents. lines up here. Okay, so you can see it prints like shorts, and then it prints a new line, and then it prints the second line. And you can have as many lines as you will. And these, by the way, these two concepts can be used together. So for example, let's create a few variables. Let's say these are the stats for our Pokemon. So we're going to have a speed of 45, special defense, let's say, is going to be 65, and special attack, let's just use a short form here. And we'll say 65 for that as well. And we'll say the defense, normal defense is 49. And the normal attack is 49, and their HP is 45. Now these are the stats of a specific Pokemon. I want to say Bulbasaur, but I looked it up a few days ago, so I forget now. So I'm going to put an F string in front of this, and I'm going to use a triple quote. Now you could use double quote, double, triple quotes if you want to. Triple, double quotes, I guess, is the right thing to say here. So what I'm going to do is I'm going to create kind of a table of stats. So I'm going to say something like this. I'll put HP, and then I'll print out the HP, and I'm going to format this a little bit later. So I'll say speed, and then we'll say special defense. That's that variable. And then special attack, and then defense. This way. Now that I think these are the longest ones, let's fix these so they line up nicely. This is something that you often don't have to do in a graphical user interface or a web application, is putting in spaces so things line up, but kind of exclusive to the console, but I still want to do it. Okay, so now if I print stats, anyway, you can see that it lines up nicely. Now we have an extra new line after attack, and we have a new line right here, so that's why we have these extra lines in here. But otherwise, so print puts a new line in there, but there's also one after the attack variable, and there's also one before the HP, so that's why there's those two blank lines. It isn't necessarily a bad thing, just pointing out to you why this is the way it is. Precision is important. All right, so let's move on to lists. Okay, so make sure I put a comment in there. I'm going to go in the same order that we did in the lecture just for simplicity. So let's create a list of moves. This is a Pokemon-themed lecture, I think. So let's create 4 moves. I don't know why, but I kind of like to make my list this way. So I just create the list, and then I put the quotes in there. And then I fill in the values after. That might not be your cup of tea, but I find I make a lot less mistakes doing it this way for whatever reason. Okay, so there's a couple of moves that Bulbasaur knows. And let's put in move damage. This is a common practice in programming where we have 2 lists, and they both have the same number of elements. And the element at index 0 for both of these lists are related to each other. So, for example, Growl, the move Growl, is the first element of the moves list, and it has a damage of 0, which is the first value of the move damage list. And Tackle has damage 40, and Vine Whip has damage 45, and Growth has damage 0. So that's how this works. Okay, so let's make a quick for loop. And so what we'll do is I'll do for I in range len of moves. So this is going to go through the length of moves. Now I could actually hard code. This is a common practice for beginner programmers. Just hard code the length of the list because I know these 2 lists are both size 4. But if I then go in and say, okay, I want to be able to reduce the number of moves to just 3, let's say, I really have to change a bunch of other things in my program. I could potentially have these for loops elsewhere in the program. Not one line later, it could be somewhere else in the program. And I don't think, oh yeah, I've got to change that. And so I forget about it, and now I've got a bug. So it's always best not to rely on these hard-coded constants. So in this case, 4 just happens to be the length of these lists, but that isn't necessarily always going to be the case. So to be on the safe side, I'm going to put len of moves in there so that it counts the number of elements. Now, I'm still relying on the fact that these have the same length. So now what I'm going to do is I'm going to print out an F string, and I'm going to print out I'm going to do something like moves at position I. And let's actually put the label in there so it says move. And then I'm going to say does. And then we're going to say move damage at position I. Again, I'll put the name in there as well. And then we'll do points of base damage. Okay. All right, so let's run this and see what it looks like. Here we go. So you can see that it prints out the move and it puts the label in there. You obviously don't need the label. If I just get rid of this equal sign bit here. By the way, if you just put the equal sign with no spaces, it'll still print the expression, but with the spaces in between the equals sign and the value. All right, so if you don't care about putting the value in there, you can just do something like this. This is something a little bit more likely that you're going to show to the user. Anyway, so there we go. So we can move through these lists based on their index. But I need to know the index. So imagine, for example, I want to do a particular move. Then I need to know what index it is within the list. And so we do have a mechanism, obviously, for doing that. And so there's, for example, I can say something like, if, let's say I want to look for tackle. If tackle in moves, so remember that expression is going to say, well, if there is a tackle string in the moves list, then what I can do is I can get the index by saying, well, moves.index of tackle is going to tell me the index of where tackle is in moves. And then I can say something like, tackle does whatever, move damage at index, points of base damage. We kind of printed that already above, but we're going to have another line now at the end that's going to print out the tackle summary again. Okay, so that's one way that I can do it, but it is it's a little awkward that I have to know the index, and so that's one of the reasons why we use dictionaries. So let me get back to dictionaries in a little bit. All right, what if we wanted to do some computation on type effectiveness? So let's say, for example, I have a move, and I can figure out that move's type. And then the enemy is a particular type, and I want to see if my move is going to be effective against that particular enemy. I need to have a type effectiveness chart. Well, the best way to implement this is to create a two-dimensional list, or a list of lists. So what I'm going to do, just to make this a little bit more readable, I'm going to have three variables, which are going to just be placeholders for the indexes in the array. This is kind of a way around the fact that using indexes is a little bit awkward. So I'm just going to define these, and they're just defined as the first three indices in our two-sided array. So I'm going to have this array called type effectiveness, and I'm going to set that equal to a list of lists. Now, rather than do it all inline like the ones that we did in the lecture, I'm going to hit enter and line these up nicely. So, for example, I'm going to have a square bracket, and each one's going to have three values in it. So just to save myself some typing, I'll copy and paste this line. So I have two commas to separate the three values within the list, and then I have a comma at the end. Notice that there's an extra comma at the end here, but that's actually allowed in Python, so it makes it easier. If, for example, I want to swap some of the orders around, let me actually put in some values, and then I'll demonstrate that. So I copied these, by the way, from the I think the first gen type effectiveness chart. So this is grass, water, and fire. And so grass against grass is 50% effective. Grass against fire is 50% effective. And grass against water is 200% effective. Okay, so there we go. And then we're going to have an extra comma in there. Okay, so just as a demonstration, let's say I wanted to move this line down. If I copy and paste it right now, it works no problem because every single line has an extra comma at the end. However, if I specifically made it so that my last line didn't have a comma, which looks more syntactically correct. So if you're not satisfied to keep that extra comma in there, would understand. But moving this line down means now that I have to erase this comma and add a comma here. And that can be kind of awkward. So that's often why a lot of programmers will put these extra commas in there, why a lot of programming languages allow for it to happen. Okay, so this type effectiveness chart is actually really easy to use now, because I could just do something like this. I could say, let's use type effectiveness. And let's say, a fire type move against a grass type move. And let's put the label in there so we can see it. And I'm going to trace this and show you how this is calculated just momentarily. But we can see that fire against grass is going to be 200% effective, or 2 times effective. And here's how it works. So type effectiveness is a list of lists, which means that type effectiveness is a list, and it has 3 elements in it. Each of those 3 elements are lists. This is the first element of type effectiveness at index 0. This is the second element of type effectiveness at index 1. And this is the third element and last element of type effectiveness at index 2. And each of those lists, of course, is a list, so we can also index that. So the first square bracket here says, which list do I want? So fire is equal to 1, so it says, give me the value at index 1. So remember, we start indexing lists starting at index 0, so 1 is actually the second one. So that's type effectiveness of fire just by itself is this. And let's actually just, let me show you that just to make sure. So getting rid of this square bracket grass part. When I run this, you can see that type effectiveness of fire shows you a list. This is a list of all the type effectiveness values for fire moves. Okay, so this is grass, fire, and water. Okay, so the first one actually resolves into a single list, which, since it's a list, this one-dimensional list here, I can now use another set of square brackets to find the element within that list. So finding grass is going to tell me, give me the first value of that list. So that's going to give me this 2.0 here. Anyway, so that's pretty useful. All right, so let's move on then to tuples. So let's talk a little bit about tuples. Now, as I said, my preference is to use dictionaries. So I was saying that before, and I know it's a little bit more typing, but it's a little bit more consistent between different programming languages. It meshes well if you're, say, a web developer and you want to interface with various APIs. They usually return a format called JSON, and JSON has dictionaries as one of its key types. So as I said, it's used in all kinds of programming languages, and it's used in web interaction. And as a result, why not? Why wouldn't I just use it in Python? It is a little bit more typing, but it's a lot more clear. If I want to access a correct field within a tuple, I have to know which index it is within the tuple. But if I want to access a field within a dictionary, I just need to know the name of the field. So tuples are a little bit more prone to error, because if you say tuples at 0, you might get the wrong value, and that's a logic error potentially, not necessarily a syntax error or a runtime error. And as a result, it's going to be tricky potentially to find that error. All right, so let's just do a few examples with tuples. Actually, they're relatively straightforward, so let me just do one for now. So let's do Pokemon 1, and I'm just going to create first the name of the Pokemon, then the type of the Pokemon, and the HP, let's say. And the index, I wish I knew. Actually, I didn't write that down. So this is a tuple. We don't put any square brackets around it, and therefore it's a tuple. So if I want to, I can do something like print Pokemon 1 square bracket 0. So you'll see that that will print. Let's put the name in there as well. It'll print Bulbasaur, so you can see that we're accessing it by the index, just like we did with the list. But the key difference here is that typically tuples are of different types, and lists are they're supposed to be the same type. Another thing you can do is you can actually loop over a tuple. So for example, I can say for value in Pokemon 1, and what I could do is print the value. So for example, I could say print the value. And I could do, of course, print, index and range. That would work as well. And there's also a len function. You could use a len function in order to determine how many values are in this tuple. So in this case, this one has 3 values, so len of Pokemon 1 would return 3. All right, so let's look now at dictionaries, which, as I said, I think it's a lot more interesting. So let's do. So if you need a lot of values of the same type, use a list. If you need values of different types that are all related to the same concept, then I would suggest use a dictionary. But if you like tuples, there's nothing against using tuples. Feel free. So let's create a dictionary for a move. So let's just call it a move. I'm going to use curly braces to indicate that it is a dictionary. And then we have these name value pairs. So what I'm going to do is I'm going to have a name, which is always a string. Then I'm going to have a colon, and then I'm going to have some kind of value. The value does not need to be a string, but sometimes they are. Okay, so first of all, I'll have the name of the move, and that's going to be a string. So I'm going to say, put quotes around it. I'm going to say the name field's value is tackle. And I'm going to have another field called base damage. And the value for that is going to be 40. And then I'm going to have a type field. Oops, not capital. I want to be consistent here. The type of this is going to be a normal type. Okay. Or if we wanted to, if we had a type effectiveness chart, I don't have normal in this type effectiveness chart. It only has 3 types. I could, instead of using the string normal, I could use one of these constants here, and then it would be an index so that I could look things up in various tables. Okay, so this is putting it all in one line, which is not super readable, but let's create another Pokemon. I'm just going to call it Pokemon 2, but we're going to put the same stuff, a little bit more stuff in it that we put in the Pokemon 1. I'm going to put this on multiple lines. I'm going to hit enter, and each line is going to be one of the fields. So I think just to make things easier, what I'll do is I'll put an empty field name and an empty string as the value. Not all of them are going to be strings, but some of them are. And then I'm just going to copy that a bunch of times. Okay, so let's go with the name of the Pokemon is Bulbasaur, and the type of the Pokemon is grass. I'm going to use lowercase for all my fields, but that's just a convention that I prefer. The HP for Bulbasaur by default is 45. Speed is 45. Now realizing that a lot of these are numeric. Special defense, I'll just use underscore for that just to be consistent, but I have to remember what this field is if I want to access this value later. So special defense will be 65. Special attack is going to be 65. But not a string, number. And then defense is going to be 49. And attack is going to be 49 as well. Again, we got an extra comma here, just like I was talking about before, so I can move these around. That's one of the nice things about dictionaries. Unlike tuples, we can change the order. If, for example, I have Pokemon 2 has them in this order where I have HP and then speed, and then I have Pokemon 3 and I accidentally put speed first and HP second, that's not going to matter. The ordering here is pretty much irrelevant. Now, to access the individual values for this, all I'm going to do in my expression is I'm going to say Pokemon 2, and then in brackets here, now just keep in mind I'm inside a string, so I can't use single quotes, so I'm going to use double quotes for the field name here, but again, you can use them interchangeably. I can print out the HP value of this Pokemon. So that's an easy way of doing this. You can see that looks up the value. And looking up by the name, which I think makes more intuitive sense to me. Not only that, but I think it helps the readability of the program. I know that I'm grabbing the HP here, whereas in the Pokemon 1, let's contrast that, I grabbed, Pokemon at 1, square bracket 2. This one grabs the HP up here. And it's not really clear that that is the HP. Maybe I have the wrong line. This one, it's very clear that it's the HP. So it cuts down on the errors. With a tuple, we were able to loop through all of the tuple values So I might want to do that if I have a dictionary. So let's see what we can do with dictionaries. Let's just do for X in Pokemon 2, and let's just see what X is. And this is temporary code. I'm going to replace it with more proper code to loop through this later. But let's see what actually prints out when we print out X. So if I loop over, if I iterate over Pokemon 2, what are the X values? So in this case, it's kind of hard to tell, but anyway, you can see that it prints out the keys. So these are actually the keys. So let me change this variable name so that my program is a bit more readable. So now I'm looping over the keys. If I want to print out every single key and the value that corresponds to it, that's actually quite easy to do. So here's what I can do. So I'll use an F string for this, and I'll just say key equals, let's say, and then we'll put maybe colon, and then we'll put the value. So we can say Pokemon 2 square bracket key. So key is a string. And I can use that string inside the square brackets with the dictionary to get the field that corresponds with that key. So that's actually quite cool. Let me put a couple spaces in here, maybe up here too, so I can see. These are indented so that it's easier to see that they're all part of a chunk. Okay, anyway, so in this case, you can see it prints out all of the keys and also the values that go with it. And obviously, I don't need the equal signs. So let's get rid of those so that it just shows us the relevant data that we need. You can see name, Bulbasaur, type, grass, HP 45. Okay, so that's like the basics of how to use a dictionary. What if I want to start combining some of this stuff together? Like obviously we are kind of combining like strings, obviously. But what if I want to have something like, a list of dictionaries? A list of tuples, by the way, is also possible. But let's create a list of all of our Pokemon in our team. So for example, I might have team equals square bracket. Let's do this on multiple lines because this is going to get pretty substantial. And then I'm going to have a bunch of curly bracketed expressions that represent each of the three Pokemon that I'm going to have in my team. 3 only because I don't want to type too much. But anyway, I'm also going to do that over multiple lines. So the first Pokemon is going to have a name. That's going to have some value. And then it's going to have a type, which is going to have some value, which is going to be a string. And then it's going to have HP. Just to save myself a lot of typing, I won't put all of the fields in. But let me put these 3 in there. Okay, so let's put those 3. Let's duplicate this 3 times so that we have 3 different Pokemon. You can see we've got commas at the end of the curly brackets. So this is a list that has 3 elements in it. This is the first element at index 0. This is the second element at index 1, and this is the third element at index 2. It just so happens that those values are dictionaries. So let's enter this value in. So let's say our first Pokemon is a Bulbasaur, and that's a grass type, and it has HP of 45. And then let's say we caught a Caterpie. This is in the beginning of the game. So we caught a Caterpie, that's a bug type, and it has 45 HP as well. All right, and the third Pokemon that we caught was Pidgey, which is a normal and flying type. Obviously, working with 2 different types could get a little bit confusing. I could maybe put types. Maybe it's a list of types. So that would be weird. I'd have a list of dictionaries, and one of the elements in those dictionaries is also a list. So maybe just to keep things simple right now, we'll just do a list of dictionaries. Okay. So let's say, for example, I want to look up let's say my second Pokemon's HP, for instance. So what I could do is I could do something like, my team is a list of dictionaries. So it's a list, and so I can use square brackets on it with the index. So the second Pokemon is at index 1. So let's see what this does. So if I just put this by itself, let's put an equal sign in there so that we can differentiate these later. It gives me the entire dictionary. Now it doesn't put the spaces and tabs and all that stuff in there that makes it nice and readable for me in my program, but it does print the whole dictionary out. Since team square bracket 1 is a dictionary, I can use square bracket notation to get an individual value. So for example, I could get the HP field of that Pokemon if I wanted to. So now when I run this, you can see that grabbing the second Pokemon's HP field is very easy to do. And it's really understandable because I used a list specifically because I have a Pokemon team and they're in a specific order. So order was important. So I actually do know the position in their team quite easily. So for instance, when you enter a Pokemon battle, your first Pokemon is the one that gets initial attacks or whatever. And that would be Team 0. So I can use the index for that. That makes sense. But then within the Pokemon itself, it makes more sense for me to use the field to avoid errors. Okay. So that's a possibility. And we could also have a dictionary with a list. And we could combine these together even if we wanted to. But let's do Pokemon 3. It's going to be a dictionary. And we're going to have a name. Fidget. And then type is, again, it's normal flying. This could be a list, but I'm going to use a different field for the list. We're going to have an HP of 40 for a Pidgey. And then we're going to have moves. So the list of moves for this specific Pokemon might be 4 strings, and we can put those 4 strings in a list. Okay, so there we go. So now this is a dictionary with a list inside it. So if I wanted to, I can access the individual elements. So an easy way to do that would be to say Pokemon 3. Now I can grab a specific field. Well, the field that I want is moves. Just keep in mind whenever I'm using the field in the square bracket, because I'm inside a print statement that has single quotes, I'm using double quotes. And I could reverse it if I wanted to. But normally I use single quotes, but here it makes more sense to use double quotes. Okay, now that itself is a list. So let's see what that looks like. So you can see it's a list of all of our moves. So what if I just want to grab the first move? So let's do that same thing, and I'm just going to grab the first move from that list. Just keep in mind, I hope I have this one, this list. So there's 2 possible ways that this could go wrong. I could pass it in a key that doesn't exist, or I could pass in an index that's invalid. They're both a pretty similar kind of error. And let's test them out. So for example, instead of moves, maybe I look for something like make a typo. In that case, see what the error we get is. So it just says key error. That's not the most descriptive error message around, but it does tell us, specifically what line of code it happened on. And it says key error, which gives us a clue it has something to do with the key. Well, if you see a key error, it just means that you're trying to access a key in a dictionary that doesn't exist. So here are the 4 keys that we do have. Here's the one that we tried to use and they don't match. Okay, so that doesn't work. And so let's comment that out. And let's try the other one, which is, what if I use an index that doesn't exist? Well, we have 4 moves. And so let's just try to access the move at index 4. So these are 0, 1, 2, and 3, right? So there is no index 4. So that's going to give us an index error. Oops, comment it out first. I always comment out the code that is actually going to cause an error, that any subsequent code will still work. But anyway, that's actually it for the examples for this particular section. So I'll see you in the next section. Bye-bye.